There are billions of stars in our galaxy alone, and around many of them, scientists believe are planets where liquid water could exist. But where is everybody? For decades, we have searched the skies for a signal, a message, even the faintest chemical fingerprint of life. And so far, nothing. But the real mystery may not be that aliens are hiding. It may be that we've been looking for life in the wrong way. Imagine standing on Earth 4 billion years ago. There are no cities, no satellites, no radio transmissions, no technology. Just oceans, volcanic activity, an atmosphere slowly changing, and microscopic life. If an alien civilization had pointed its most powerful telescope at Earth during that era, would it have known life existed here? Probably not. And that simple idea changes the entire question. Because when scientists search for extraterrestrial life, they aren't necessarily searching for creatures that look like us. They're searching for evidence. A chemical imbalance in an atmosphere, organic molecules, unusual gases, radio signals, or some phenomenon that is difficult to explain through ordinary chemistry and physics. But there is a problem. Space is enormous. Our galaxy contains hundreds of billions of stars, and the observable universe contains an almost unimaginable number of galaxies. Even if life is common, the distance between living worlds could be enormous. And here's where the mystery becomes even stranger. Scientists have already discovered thousands of planets outside our solar system. Some orbit within what researchers call the habitable zone, the region around a star where temperatures could potentially allow liquid water to exist on a planet's surface. But habitable does not mean inhabited. Venus is roughly in the same broad planetary neighborhood as Earth, yet its surface is an extreme environment. Mars once had rivers and lakes, but today its surface is cold, dry, and hostile. So finding a potentially habitable planet is only the beginning. The next problem is detectability. Imagine an alien civilization observing Earth from dozens of light years away. They might detect oxygen in our atmosphere. They might notice methane. They could potentially see signs that something unusual is happening. But would they immediately conclude life? Not necessarily, because the same gases can sometimes be produced by non-living geological or chemical processes. So scientists face an extraordinary challenge. They must distinguish between a planet that merely looks interesting and one that actually contains biology. And this is why the search for alien life has become much more sophisticated. Researchers aren't simply asking, is there water? They're asking something far difficult. Does this planet show a combination of chemical signatures that life is the best explanation for? That distinction matters, because the universe may not be silent at all. We may simply be listening for a voice when life is communicating in a language we haven't learned yet. And there is another possibility that scientists find especially unsettling. What if simple life is common, but intelligent life is extraordinarily rare? Earth spent billions of years with life, yet technological civilization appeared only in the final fraction of the planet's history. That means the universe could contain countless living worlds, while almost none ever produce a species capable of building a radio transmitter. If that's true, then the famous question, where is everybody, has a very different answer. Maybe there is nobody close enough to hear, or maybe intelligent civilizations exist, but their signals have already passed us. Because when we look into the night sky, we're not seeing the universe as it is now. We're seeing its past. A signal traveling across space can take decades, centuries, or millions of years to arrive. And that means the civilization we are searching for may not exist anymore, or it may not have existed yet when its light began the journey towards us. The deeper scientists look, the more the mystery changes. The question is no longer simply, why haven't we found aliens? It's becoming something much more profound. What would alien life actually look like if we had no idea what to search for? And one recent shift in planetary science may bring us closer to answering that question. Because scientists are beginning to look beyond the planets that resemble Earth and toward worlds that, at first glance, seem almost completely wrong. One of the most important discoveries in the search for life is that Earth may not be the only kind of world capable of supporting it. For years, scientists naturally focused on planets that looked familiar: rocky worlds, moderate temperatures, liquid water. But our own solar system has complicated that picture. Far beyond Mars, hidden beneath enormous layers of ice, are worlds like Europa and Enceladus. They are frozen on the surface, yet beneath that ice, scientists have strong evidence for global oceans of liquid water. And in the case of Enceladus, something extraordinary happens. Powerful jets of material erupt from beneath its icy surface and spray into space. Those plumes contain water and other compounds, giving scientists a rare opportunity to study material originating from an underground ocean without drilling through kilometers of ice. That changes the search completely. Life might not need a warm Earth-like surface. It could potentially exist in an ocean hidden beneath kilometers of ice, protected from the harsh environment of space. And if that is possible, there could be habitats throughout the galaxy that our traditional searches barely notice. But there is still a deeper problem: distance. Even if intelligent civilizations exist, our galaxy is so enormous that two civilizations could be separated by thousands of light years. A radio signal travels at the speed of light. That sounds incredibly fast, but across interstellar distances, even light can take an extraordinarily long time. A civilization could send a signal today, and another world might not receive it for centuries. And by the time the message arrives, the civilization that sent it might have disappeared. This leads directly to one of the most haunting ideas in astronomy: the Great Filter. The Great Filter is not a proven phenomenon. It is a hypothesis, a possible explanation for why we don't see obvious signs of advanced civilizations despite the enormous number of potentially habitable worlds. Perhaps life almost never begins. Perhaps complex cells are extraordinarily difficult to evolve. Perhaps intelligent life rarely appears. Or perhaps civilizations reach technological capability and then fail to survive. We don't know which possibility, if any, is correct, and that uncertainty is exactly what makes the mystery so powerful. But scientists have learned something important from our own planet. Life is remarkably adaptable. Earth's organisms survive in boiling environments, deep beneath the ocean, inside Antarctic ice, and in places with almost no sunlight. That means the boundary between habitable and inhabitable may be much more complicated than we once believed. And future telescopes are giving scientists a better chance to investigate distant worlds. Instead of looking for little green creatures, researchers can study the light passing through a planet's atmosphere. That light can reveal chemical fingerprints. A future discovery of a convincing combination of gases, especially gases that should not coexist for long without a continual source, could become one of the strongest clues yet that biology exists beyond Earth. But even then, scientists would have to be careful. A single unusual molecule would not prove alien life. Science demands something harder, evidence that survives every alternative explanation. And perhaps that's the real reason we haven't found aliens yet. Not because the universe is empty, not because intelligent civilizations are hiding from us, but because the evidence is incredibly difficult to recognize from thousands or millions of miles away. For most of human history,
We didn't even know planets existed around other stars. Now we know they're everywhere. We've discovered worlds with scorching atmospheres, planets orbiting two stars, frozen moons hiding oceans beneath their surfaces, and countless environments that challenge our old assumptions about where life could survive. And the search is still in its earliest chapter. Maybe the first alien life we discover won't be a civilization. It may be microscopic. It may exist beneath the ice of a distant moon, or it may be revealed by a tiny chemical imbalance in the atmosphere of a planet hundreds of light years away. And when that day comes, the discovery may not answer the biggest question. It may create an even bigger one. Because if life evolved independently somewhere else in the universe, then life may not be a rare accident. It may be a cosmic tendency. And suddenly, the silence we've been hearing for generations would mean something very different. We weren't alone. We were simply too early to hear the answer.